Through an AFL drop punt set shot kick for goal, the biomechanical principles involved will be explored, which will outline the effects of projectile motion and velocity of the AFL drop punt kick. Biomechanics is an in-depth study of the agile changes of the human body through mechanical movements and the biological muscular system. Analysis of the body's muscular and skeletal movements can help indicate areas of improvement. Through the AFL drop punt kick, there are 4 stages that, when in sequence, lead to an increase in velocity, the speed in which an object or body is moving, acceleration, and momentum of the ball and body. The preparatory phase is the initial phase in which occurs after the mark is taken and the run-up distance from the man on the mark is measured and walked out, with 15 to 25 metres being taken prior to approaching the goals. This allows for momentum to build up in the approach phase. Prior to approaching the goals, the player concentrates and positions the body in line with the targeted direction of the goals where the body is stable. The centre of mass is inside the base of support, stabilising the body prior to the approach phase through static equilibrium. The approach phase follows the preparatory phase, where general motion, the combination of linear and angular motion, becomes the greater factor in the increased motion and momentum of the body through internal forces. The angular motion through the hips, knees and ankles align the body in a linear fashion in the desired direction of the goals. Isotonic forces are present where the leg muscle length shortens and lengthens to create force through motion and to maximal force. As the player is running in the direction of the man on the mark, the dynamic equilibrium of the body creates movement while being balanced prior to the kicking phase, where the body's centre of gravity remains inside the base of support. The body has momentum, an object or body that has motion, through the approach phase, with the body's mass being proportional to its velocity, guiding the body in the direction of the goals. As the second to last step of the approach phase is taken, there is a greater increase in angular motion through all joints, with velocity increasing through the withdrawal/kicking phase. As the right foot is planted, the left hand releases off the ball, where the base of support is smaller as the body is in motion, with the left arm acting as a counter lever, which is used to balance and stabilize the body and the body's center of gravity outside the base of support. As the left leg becomes planted, as the base of support is reduced in size as the body slightly leans backwards, allowing for a greater increase of angular motion through the hips, with the center of gravity being dragged in the direction in which the limb is moving. Momentum, velocity and force are built up through the right leg as the ball is dropped from in line with the hip. The angular motion pivoting from the hips, driving the leg up, increases lever length, with the knee and leg straightening, increasing the force applied, with the left arm dragging the center of gravity back towards the inside of the base of support, maintaining stability when the contact is made between the foot and the ball. There is a greater resistance from the ball contact on the foot, with a third class lever being present, with the ball being the load, the hamstring and quads being the effort, and the hips being the fulcrum. The movements of the larger muscles of the hamstrings and quadriceps occur first, before the calf muscles follow, where maximal isotonic contraction is present. Through the sequential formation of the kicking phase, the initial movement of the hips is followed by the knee once the previous muscle group of the hips has reached their maximal output. The movement of the ankle then follows, all working in sequence to generate force as the foot makes contact with the ball. There is a rebound effect and elasticity within the ball where Newton's second law is present, with the force required to kick the ball is equal to the acceleration of the leg and the mass of the ball as the foot makes contact with the ball. After the withdrawal/kicking phase, the body stabilizes itself through the recovery phase. After the ball has left the foot, the body's center of gravity moves outside the base of support so that the stabilization of the left leg follows the direction of travel after lifting off the ground, before the body's base of support becomes the right leg, which is planted on the ground, aligning the body as the follow-through steps begin to occur. All body parts begin to sequentially stabilize once the body parts are all in momentum in the follow-through. Projectile motion is the motion of an object that moves through the air, with the object's predetermined parabolic path being only determined by gravity and air resistance as external forces. With force and momentum being passed onto the ball through the contact phase, the ball becomes a projectile once it has left the foot. Projectile motion is present through the ball following the predetermined parabolic path towards the goals in the direction of travel. Gravity is an external force that pulls the AFL ball to the Earth's surface, creating the arc of the ball's trajectory. Gravity decelerates the ball before it reaches the top of the arc, before it passes through the goalpost on a downward path, accelerating with downforce being applied on the ball to bring the ball to the Earth's surface behind the goals. Air resistance creates dramatic changes to the trajectory of the AFL ball, with external forces shortening and lengthening distance. While the AFL ball is in flight, there is drag force applied by air resistance, impacting the ball's velocity and blunting its predetermined parabolic path, with the ball's backspin fighting the external forces. While kicking with the wind, air resistance can carry the ball for a greater distance, but while kicking into the wind, it blunts the predetermined parabolic path, dramatically shortening distance. The main effect on projectile motion of the AFL ball is its spin. The Magnus effect is present, with the ball having backspin, where forces on the ball are moving upwards with the air being reflected downwards along the ball, promoting the lift of the ball due to the rotating backwards and upwards towards the sky around its center of gravity and mass, with the velocity of the ball being further increased. With the backspin on the AFL ball, the top of the ball is an area of lower pressure resulting in the lift of the ball. The speed at which the ball is released off the foot after contact greatly determines the distance the ball travels, as the speed is transferred through the ball, creating it to greatly accelerate, maximizing the force that is being applied to the point of contact for the longest time possible before the ball becomes a projectile. The height of release occurs between 0.1 and 0.3 meters off the ground at the point of contact between the foot and the ball. The height at which contact occurs affects the angle of release, where the optimal angle of release is 42 degrees to allow for maximal horizontal distance and a slight gain in height from the ball drop. The angle of release of an AFL drop punt kick is less than 45 degrees, as the object does not start and finish at the same level due to the height of release being above the ground. Through the comparison of myself and the professional AFL player of Gary Ablett Jr., all phases are slightly different. Within the preparatory phase, Ablett steps out 20 metres away from the man on the markers, whereas I start 15 metres away. Ablett composes himself lining up the ball in the direction of travel, whereas I'm looking down at the ball, positioning it in my hands. As the approach phase begins, Ablett has an extra 5 metres to build up momentum through his kicking technique, with myself beginning to start my running strides and building momentum after only 4 walking steps and 1 small skip, compared to Ablett taking 9 walking steps and 6 little skips to get momentum, then 4 running strides before he kicks through the ball on the 5th running stride, with the base of support being his left foot, which is the same as myself being a right foot kicker. Within the withdraw/kicking phase, there is an increase in acceleration of the kicking leg through angular motion through the hip joint, with as the base of support is both myself and Ablett's left foot. Our left hand comes off the ball, but the point at which the arm lifts to as the counter lever is different. Ablett's arm becomes level with his shoulder after releasing from the ball, leading to a greater stabilization of his body, with his base of support being inside his center of gravity, equaling out the momentum of the body, whereas my arm lifts past my head and does a circle before finishing by my left side, opening up my hips as I lean my body backwards, thrusting my leg through with force and momentum of angular motion of pivoting from the hips. Both myself and Ablett drop the ball from in line with our hips, the height of release, guiding it onto the foot at the point of withdrawal, but Ablett's ball drop consists of his hand more on top of the ball rather than on the side like myself, where my middle finger lines up with the side seam of the ball. As both myself and Ablett make contact with the ball, our lever length is also increased, with the ball making contact with the straight leg, increasing the impulse and the submaximal force required. The angle of release is different, with myself having a 36-degree angle compared to Ablett having the optimal angle of release for an AFL kick of 42 degrees, due to the height of release allowing Ablett to achieve his maximal distance and accuracy with momentum, force, and angular motion. Through angular motion and lever length, the arc of the hip and leg movement prior to the foot making contact with the ball is different between Ablett and myself, where I measure 114 degrees compared to Ablett measuring 170 degrees, with Ablett having a greater range of leverage of the leg through greater range of angular motion. Through the recovery phase, I land back on my left leg before transferring weight to the right leg as a base of support, where I then take a further 5 steps towards the player standing on the mark using linear motion, whereas Ablett lands back on his left leg before transferring weight to his right leg as a base of support, but then stops still on both feet and does not follow through. Through the sequential formation and selective recruitment, both myself and Ablett were able to perform the skill of kicking a goal. The initial movements of the kicking phase had the same timing, which consisted of the hips, knees, shoulder, wrists, and then the ankle, all following and working in sequence, generating the submaximal force to make contact with the ball. Both myself and Ablett have the same sequence of muscular movements and contractions, with the movements of the larger muscle groups beginning first with the hamstrings and quadriceps first before the calf muscles, then followed by the maximal isotonic contraction is present.